This video will briefly walk through the Boulder Desertification Dashboard developed by Linker for the City of Boulder. Looking at the top right of the screen, we have two sections. The home is the landing page for the dashboard as you see it here, and About provides a brief overview of the motivation and methods that govern this project. So before we get started, we'll touch on some of the main points from the About page. We developed a multi-scale assessment and monitoring framework to track land degradation in Boulder County. Using open source remote sensing data, we created fine scale risk scores that integrate four key sectors: land productivity, land cover, soils, and water. The framework analyzes trends from 2000 to 2023 at both pixel and parcel levels. So with that quick background, let's jump into looking at the dashboard itself. A quick note on this layout: there are two main tabs in the dashboard. The framework results, shown here, and the trends each show different types of data. The framework results visualize scores for each pixel and year, and the trends tab summarizes trends and results over time. And we'll return to this in a moment. On the left panel, you'll find the map controls. Here you can choose which data layer to view, adjust the layer's opacity, and read a short description of what's being shown. If you hover over the top left corner of the map, the layer waffle icon will allow you to toggle map layers on and off. This is located below the zoom controls on the map. You'll notice the City of Boulder Open Space and Mountain Parks, OSMP, and Boulder County Parks and Open Space, BCPOS parcels are displayed on the map. Open Space Mountain Parks parcels are in the solid blue lines, and Boulder County parcels are in the dashed blue lines. These properties were used as representative parcels selected by the project core team. Additional layers include the city's 2023 prairie dog colony survey, the 2020 irrigated lands layer from the state, and a water rights layer developed by Linker to show relative water rights seniority across parcels in the study area. These can be accessed by clicking this layer waffle icon again on the map. The legend for the active layer is shown on the bottom right side of the map over here. Now let's get into accessing the data. So you can choose the data you'd like to view on the data tab. You'll see there's drop-down options in the map controls under data source, which include the data layer, the year selection, and the score type. Walking through the first data layer in the first drop-down, 30-meter data, you can visualize results for land cover, land productivity, soil, and water, along with an overall land condition score ranging from -2 to 2, denoted by brown to green color scale. You can also select the year and the score category using these drop-down menus. The map layers displayed to the right will automatically change based on your selection. For example, if you wanted to view the 2020 land productivity score, you can change your drop-down selection to see new output. In the second item in the first drop-down, it lets you view the output of the k-means clustering scoring. In short, this machine learning approach groups areas with similar scores over time. This helps to reveal patterns across the landscape, from degraded and unstable areas to those that are healthy and consistently stable. For example, looking at the k-means clustering section, you'll notice that aggregated across the entire time frame are cluster scores ranging from 1 to 6, where cluster 1 in dark brown represents the worst land condition scores, gradually improving to cluster 6 in teal, which represents the best land condition scores. Now let's move over to the Trends tab. And the layout remains the same, but you'll notice how the data layers here are further processed and grouped based on the time period. So early, full, recent, and late. We track changes in land health scores over 4 time periods to see which areas are improving or degrading. We analyzed this over the early period from 2000 to 2023, the late period from 2014 to 2023, the recent period from 2019 to 2023, and then the full period from 2000 to 2023. Each layer shows pixels categorized as one of 3 states: positive trend shown in green, negative trend shown in brown, and stable or neutral in yellow. If you would like to focus on the statistically significant trends, then you can select the significant trends in the controls. This highlights statistically significant trends with p-value below 0.05 or is near significant trends with a p-value below 0.25. Once selected, the map now overlays as shaded polygons, red areas for those areas that are significantly decreasing, and blue areas that are significantly increasing.